Good morning, students. Just after the completion of group 16, that is oxygen family, next today in class 1 of the chapter group 15 element or nitrogen family, I will try to complete the introduction part, electronic configuration, general trends in physical property, general trends in chemical property, and anomalous behavior of nitrogen. So let us discuss one by one. The topic is nitrogen family. Nitrogen family. That is, or it is group 15 elements. Group 15 elements or nitrogen family. So first is introduction part. Mark that. First one is introduction. The elements nitrogen, phosphorus, arsenic, antimony and bismuth. I repeat again. The elements nitrogen, phosphorus, arsenic, antimony and bismuth constitute the group 15 element or fifth A of the periodic table. As during electronic configuration, the last electron enter to the p orbital, p subshell. That's why it is also belongs to p block element. Already we discussed. The total extended form of the periodic table is classified into 4 block, S block, P block, D block, and at the bottom that is known as F block, depending upon the electronic configuration. That is last electron enter either S or P or D or F subshell. Among them, nitrogen, phosphorus, typical nonmetal, arsenic, antimony, the metalloid, while bismuth is metallic in nature. Next, we discuss about the electronic configuration. Next is electronic configuration. From the electronic configuration, it is clear that they have 5 electrons in their valency shell, showing common outermost electronic configuration NH2, NP3. That means they have a strong tendency to attract an additional 3 electron to get the nearest noble gas configuration. Mark that in the form of a table that is known as element, atomic number, next noble gas electronic configuration. Nitrogen, phosphorus, arsenic, antimony, bismuth. Atomic number 7, 15, 33, 51, 83. Noble gas configuration helium 2, 2s2, 2p3. Next, neon 10, 3s2, 3p3. Argon 18, 3d10, 4s2, 4p3. Krypton, helium, neon, argon, krypton, 4d10, 5s2, 5p3. Xenon 54, 4f 14, 5d10, 6s2, 6p3. Mark that. From this noble gas configuration, it is clear that outermost is 2s2 2p3, 3s2 3p3, 4s2 4p3, 5s2 5p3, 6s2 6p3. A common is ns2 np3. So that means they have 5 electrons in their valence shell. So they have a strong tendency to get additional 3 electrons to become noble gas, to attain the noble gas configuration. And from this electronic configuration, it is clear that since the last electron enter into the p subshell, so they are belongs to p block of the periodic table. Next, discuss to general trends in physical property. Next, we discuss general trends in physical properties. Point 1, atomic radii. First, we discuss the atomic radii. If we compare the atomic radii of the elements of group 15 with the respective element of group 15, it has been observed that the elements of group 15 possess lower atomic radii due to increase in nuclear charge. However, this value gradually, if we move from top to bottom, this value gradually increases due to increase in atomic number, successive addition of new orbit. So atomic radii gradually increases moving from top to bottom. Move to next one, that is known as ionization energy. Second point, ionization energy. What is ionization energy? It is defined as the amount of energy required. It is defined as the amount of energy required to remove the valence electron of a neutral gaseous atom to form a monovalent positive ion or cation. So, due to the stable configuration, mark that, I repeat again, that is NS2 NP3, just half filled, we know in class 11 in atomic structure, that is half filled and full filled orbital are found to be extra stable. So due to half filled p orbital, they possess higher stability. Due to higher stability, they have high value of ionization energy. However, while moving from top to bottom, this value gradually decreases as the nuclear charge increases, atomic size increases. Move to next one, electronegativity. Next one is electronegativity. Due to small in size, that means first member, that is a nitrogen, possess higher value of electronegativity. However, this value gradually decreases However, this value gradually decreases on moving from top to bottom in the periodic table. Next we discuss another property, that is a metallic and non-metallic character. Next one is metallic and a non-metallic character. If we look after the various members of this family, then it is clear that metallic character gradually increases while non-metallic character gradually decreases. For example, nitrogen, phosphorus are non-metal, arsenic and antimony are metalloid, while bismuth is a typical metal. So metallic character gradually increases or non-metallic character gradually decreases. Move to next property, that is a physical state. Next is the physical state. Mark that. The members are nitrogen, phosphorus, arsenic, antimony, bismuth. First member is nitrogen. Due to small in size, in case of nitrogen, due to small in size, there is a sidewise overlapping of a p orbital, two nitrogen atom. Among them, there is a sidewise overlapping of a p orbital, resulting the formation of a p pi overlapping, p pi overlapping. Due to small in atomic size, between the two nitrogen atoms, there is a overlapping of sidewise overlapping of p orbital. That means that is known as p pi overlapping, resulting the formation of n triple bond n. That's why, due to weak forces of attraction, it is a diatomic N2 and is gaseous in nature. While in case of other element, that is a nitrogen, phosphorus, in case of other element, due to large atomic size, sidewise overlapping of p orbital does not take place. So what happened? Four phosphorus atom join linearly to form tetraatomic P4 molecule. Due to joint structure, magnitude of van der force increases. So other members of this family exhibit in solid form. Next we discuss about allotropic form. Next, sixth point, allotropic form. What do you mean by two terms is there? One is allotropy, one is allotropic form. The various form of one element, the various form of the same element, having same chemical property, similar chemical property, but different physical property are known as allotropes. And the phenomenon is known as allotropy. Among this family, that is nitrogen and bismuth, among this family, nitrogen and bismuth unable to exhibit allotropic form. Among this family, nitrogen and phosphorus unable to exhibit allotropic form. While phosphorus exhibit in three allotropic form, that is red phosphorus, black phosphorus, white phosphorus. Phosphorus exhibit in three allotropic form, that is a red form, black form and white form. On the other hand, arsenic and antimony exhibit two allotropic form, that is gray gray form, and yellow form. I repeat again. The phosphorus exhibit in three allotropic form, that is a red form, black form, white form, and arsenic antimony exhibit two form, gray form and yellow form. While nitrogen and bismuth unable to exhibit the allotropic form. Next we switch over to another characteristic property that is known as oxidation state. Next property, oxidation state. From the electronic configuration, from the outermost electronic configuration, from the noble gas configuration, it is clear that they have 5 electrons in their valence shell, that is NH2, NP3. So they have 5 electrons in their valence shell. As the first member, that is a nitrogen. Very small in size, higher electronegativity. So it has a strong tendency to withdraw, to attract 3 electrons, forming the noble gas nearest noble gas configuration. So, by accepting 3 electrons, it is exist in form of N3 minus, exhibiting a common oxidation state of -3. I repeat again, due to small in size, higher electronegativity, nitrogen accept 3 additional electrons exist in form of N3 minus and show a common oxidation state of -3. So all the members of this family exhibit a common oxidation state of -3. However, while moving from top to bottom, as atomic size increases, electronegativity decreases. So withdrawing nature decreases, donating nature increases. So to show the oxidation state of -3, that is a -3 oxidation state, showing the nature gradually decreases. That means other members of this family, in addition to the -3, they also exhibit an oxidation state, that is a positive oxidation state of +3 and +5. Nitrogen does not exhibit positive oxidation state normally due to the absence of a vacant d orbital. Excitation is not possible. Mark the box-like diagram. Nitrogen, that is helium to S2 to P3. B12. Except beside nitrogen, there is a phosphorus, neon, 3S2, 3P3, box-like diagram. 3S, 3P, 3D. It is in ground state. Mark that. As there is absence of d orbital, so excitation is not possible. So positive oxidation normally is not able to exhibit. But in case of other members of this family, due to the presence of a vacant d orbital, and also while moving down the group, While the electronegativity decreases, withdrawing nature decreases, so donating nature increases. As it is 3 unpaired electron exhibit a common oxidation state of a +3. And on excitation it is first excited state electronic configuration, that is it is 3s, 3p, 3d. Mark that. Since 5 unpaired electrons are there, so donate 5 electron exhibit a common oxidation state of +5. So other members of this family, in addition to common oxidation state of -3, they also exhibit an oxidation state of +3 and +5. It is all about the general trends in physical property. Next, switch over to general trends in chemical property. Next is general trends in chemical properties. Point 1 is affinity towards hydrogen. Affinity towards hydrogen, that is formation of hydrides. All the members of this family form hydride of the type MH3. Mark that. Of the type MH3, where M, member of the family, nitrogen, phosphorus, arsenic, antimony, bismuth. So they form, that is NH3, PH3, SH3, SbH3, BiH3. These are known as hydrides of nitrogen family. Its name is ammonia, phosphine, arsine, stibine, and it is bismuthine. These are known as hydrides of the member of the nitrogen family. Next we discuss some characteristics of these hydrides. Next we discuss characteristics, properties of hydrides. Let us discuss some characteristics, properties of the hydride. So many characteristics are there. Let us discuss one by one. That means basic nature, melting point, boiling point, reducing nature, oxidizing nature, boiling point, bond angle, so many are there. Let us discuss one by one. The first one is basic nature. So the members are NH3, PH3, ASH3, SBH3, BiH3. All the members, if you discuss about the first one, that is ammonia, is basic in nature due to the presence of lone pair of electron. Due to the presence of lone pair of electron, all the members of this one are known as the basic in nature. And this nature gradually decreases as NH3, PH3, ASH3, SBH3, and the last one is BiH3. Next, to discuss about a melting point. As we know that the first member, nitrogen, due to smaller in size and higher electronegativity, there is a presence of intermolecular hydrogen bonding. So, possess high value of melting point. However, this value gradually increases from phosphine to bismuth in a regular trend. Mark that the order is PH3 less than ASH3 less than SBH3 less than BiH3 less than NH3. That is, possess highest value of a melting point due to the presence of intermolecular hydrogen bonding. Next is boiling point. The boiling point also changes as PH3, ASH3, NH3, SBH3 and BiH3. That means boiling point increases regularly from phosphine to bismuth. I repeat again. Boiling point increases regularly from phosphine to bismuth. However, that is ammonia possesses higher value of a boiling point due to small in size, higher electronegativity, intermolecular hydrogen bonding is there. Next we discuss the reducing nature. Reducing nature means act as a reducing agent. What do you mean by reducing agent? Agent who helps in reduction of other. Who helps in gaining, reduction means gain of electron, oxidation means loss of electron. So one species who help in gaining of other means itself lose electron. So that means reducing nature gradually increases as NH3, PH3, ASH3, SBH3, BiH3. I repeat again. Reducing nature, reducing agent. One who help in others reduction. One who help in gaining other. So itself try to lose. So it depends upon the electronegativity. As it also possesses higher electronegativity, tendency to lose electron decreases. So this is the order of that is reducing nature. Next we discuss oxidizing nature. We know that oxidizing nature, oxidation is the opposite of reduction. So this value changes as NH3, PH3, ASH3, SbH3, BiH3. Next is bond angle. That is NH3 and PH3. They are similar bond angle. That is exhibit sp3 hybridization, band-like geometry. But due to the large in atomic size, the bond angle gradually decreases. Mark that the bond angle is bond angle NH3, PH3, ASH3, SbH3, BiH3. Mark that. We know in ammonia, nitrogen exhibit the bond angle sp3 hybridization band-like geometry. Bond angle is 107 degree. That means it is 107. It is 94, 92, 91, 90. Mark that. The bond angle gradually decreases. Next and the last point is thermal stability. Thermal stability. As we know, in case of ammonia, due to small in size, higher electronegativity, there is a presence of intermolecular hydrogen bonding, so it is more stable. And this stability gradually decreases as NH3 greater than PH3, ASH3, SbH3, BiH3. So these are some characteristics and properties of the hydrides of a group 15 element. Next, so you have to next one, affinity towards oxygen. That means formation of oxide. Second chemical property, that is affinity towards oxygen. That means formation of oxide. The members of this family form two types of oxide, that is M2O3 and M2O5, where M is known as the member of this family. So if we compare to the first member, that is nitrogen, it is form N2O3 and N2O5, nitrogen trioxide and nitrogen pentoxide. So in addition to this oxide, nitrogen also exhibit N2O, NO, NO2, N2O5. Mark that. I repeat again. In order to exhibit two oxide, that is N2O3 and N2O5, nitrogen also exhibit another oxides, that is N2O, NO, nitrous oxide, nitric oxide, nitrogen dioxide, and nitrogen pentoxide. And if we look after this one, if we look after the trioxide, members of the different members of the trioxide, that is N2O3 nitrogen, P2O3 phosphorus, arsenic, antimony, bismuth. Among these, if we observe their behavior character gradually changes. Means acidic nature gradually decreases, basic nature gradually increases. For example, if we compare, these are the acidic in nature, it is amphoteric nature, while this one is basic in nature. That means acidic nature gradually decreases and basic nature gradually increases. If we compare the pentoxide, if we compare the different pentoxide, that is N2O5, P2O5, AS2O5, Sb2O5, Bi2O5. If we compare the pentoxide of the members of this family, then all the pentoxides are acidic nature, but the acidic nature gradually decreases. Acidic nature gradually decreases. It is all about the characteristics about the formation of oxide or affinity towards oxygen. Next we discuss the third chemical property, that is affinity towards halogen, means formation of halide. Next one is third chemical property, affinity towards halogen, means formation of halides. Members of this family form two types of halide. That is, one is trihalide, one is pentahalide. If we look after the trihalide, then among the trihalide, NF3, except NF3, all other trihalides are less stable. Only one is more stable among the trihalide of nitrogen. If we compare about the pentahalide, nitrogen are unable to form pentahalide because of absence of a vacant d orbital. Because of absence of a vacant d orbital, excitation of electron is not possible. Other member, however, able to form the pentahalides. These are some characteristic properties of affinity towards halogen or formation of halides. Next we discuss about the anomalous behavior of nitrogen. Next, anomalous behavior of nitrogen. Like in other cases, that is oxygen of group 16, chlorine of group 17, nitrogen also of group 15 exhibit different behavior, peculiar behavior, abnormal behavior from other members of this family. Here, two questions are there, each carrying 2 marks. Point 1. Why nitrogen behaves abnormal behavior from other members of the family? Question number 2. What are the abnormal behavior? What are the different behavior shown by the nitrogen? So let us discuss one by one. That means point 1, due to small in atomic size, higher electronegativity, and third one is absence of vacant d orbital. I repeat again. The 3 main important points are there. Point 1 is due to the small atomic size, higher electronegativity, and absence of vacant d orbital, nitrogen exhibit different behaviors from other members of this family. Next we discuss what are the different behavior. Anomalous behaviors are 4 to 5 points are there. Let us discuss one by one. Point 1 is nitrogen is a gas while other members of the family are solid. Mark that. Point 1. Nitrogen is a gas while others are solid. Point 2. Nitrogen is diatomic while others are tetraatomic. Next point. Nitrogen does not exhibit allotropic allotropy while other members exhibit allotropy. Next, due to small in size and higher electronegativity nitrogen form intermolecular hydrogen bonding, while other members, due to their large size, unable to show this property. Next, due to small in size, nitrogen exhibit sidewise overlapping, resulting in the formation of p-pi overlapping, while others are not. Mark that. We discuss one by one. Nitrogen is a gas while others are solid. Nitrogen is a diatomic while others are tetraatomic. Nitrogen does not exhibit allotropic form. And due to small size, higher electronegativity, nitrogen exhibit intermolecular hydrogen bonding while others are not. So this property. And last one, due to small in size, nitrogen exhibit sidewise overlapping, resulting the formation of p-pi overlapping, while others are unable to exhibit this type of p-pi overlapping. This is the important, so many points are there, that is anomalous behavior of nitrogen.